Okay, today's video is going to be about hacking an old school NES game controller and being able to connect it up to any sort of microcontroller or Raspberry Pi or anything like that to be able to drive your projects around. So what I've done at the moment is I have cut the cable from the controller where it comes out onto his normal plug, and on the cable end, on the controller end, I've put on some dew point connectors. And that's just so I can plug it into my ESP32 board, but I could be using an Arduino or a Raspberry Pi, it wouldn't matter. Now, this here's the pin out for the plug. You can see the plug just there like that. Now what happens is in that plug, we have a number of pins that are not connected. The plug, what it has is it has a voltage plus and a ground, the power supply that supplies it, and then it has 3 data pins. I'm going to be using 3.3 for my power supply because that's what my ESP32 runs off, but you can use either 3 volt or 5 volt. The controller itself doesn't care. And then there's 3 data pins. And the protocol, the way it works is you, first of all, to initiate a read of the state of the buttons on the controller, is you pulse the latch line. You send it high, then you send it low. Then what will happen is you can read the data and it will tell you the status of the first pin. If it's 0, if it's low, it means the button's pressed. If it's high, it means the button isn't pressed. Then when you want to read the status of the next button, you pulse the clock line. You send him low, then you send him high again, and then you can read the data for the next pin. And when you want to read the next button, you pulse him low and high, and then you read that one there. So you just do that back and forth. Anytime you want to restart the sequence, you just pulse the latch to start the sequence all over again. So now we need to work out which one of these wires goes to which part, which is your power supply and which is your data pins and which ones are which. Right, so this is my pin out here, this is my cable here. So first I'm going to start off looking for my voltage. I'm going to look for the ground, I'm going to look for my 3 data pins. So what I've done is I have my tester set to bell tester for continuity. So he beeps when I touch him. So I put him in there in the voltage plus pin. I can go to my wires at the other end here. I can touch them until I find which one beeps. Oop. And it's the red wire. So it's not all that surprising that the red wire is voltage plus. So what I do is I write that down on a piece of paper. Right, so I write down voltage plus is red. Next one I'm going to look for is going to be my ground, which is that pin there. It's the same thing, I go across all of them. I think you'll find it's the yellow one. So it's the yellow one there, so I write down ground is yellow. Next one I'm going to look for is my clock, which is that one there. And I happen to know he is brown. So I write down brown over there. I'll continue on as well for my latch pin, which of course is blue because I've already done this once before. Let me write him down. And my last pin at all is going to be white. So now I know what all my pins are. So now what I can do is I can get my controller here and I can plug it into the pins on my microcontroller, and I can write a little program to read the status of which button's been pressed on the controller. Okay, I've hooked up my my controller to my little ESP32 and I've wrote down how I've hooked it up. Obviously the V plus went to 3.3 and the ground went to ground, and the 3 pins I chose to hook my data pin up was 25, 26 and 27, right, which I need to know in my software. Right, so when I do my software here, it is written in MicroPython, which is very, very similar to the Python you use if you're using an Raspberry Pi. If you're going to write in Ardunio IDE, you'll have a little bit of modification in order to get the software to go there. So to begin with the first line, from machine import pin. That's MicroPython for importing the pins. If you're using Raspberry Pi, you'll input the RGPIO library in order to operate the pins. So I set up my first pin, I call it data SNES, and it's pin 27, and I've set it up as an input pin because we're going to be reading the state of the data pin. Then I've set up latch as pin 26, and I've set it up as an output pin because we need to pulse that. Then I set up clock and pin 25 again as an output. It's going to be pulsing it. I've made myself a little function for reading the state of all the buttons on the controller and then returning it as an array. So first of all, I make the array. This particular controller I have only has 8 buttons. There's 4 for the direction, then there's 2 for the start, that's 6, then there's 7 and 8. These buttons up here are the same button as that one, they're just a rapid fire button. But there are other controllers that have buttons on the top and that these 4 buttons are actually different. They're not the repeat of the same bit there, which you'll see in a little bit. So I've used an array that's 8 big and I've set them all to 1 or high. Because how it works is when you read the data, if it's set to high or 1, it means the button isn't pressed. When you press the button down, it will pull it down to 0 or false to set it to low. Right? So the sequence is, we start off with the latch low and the clock high. So whenever we pulse the latch, we return it to low, but when we pulse the clock, you return it to high. So they actually, the clock's inverted and the latch is the right way out. Right, so we start off with latch low, clock high, and what you do is you pulse the latch once. You send it high, you send it low. Then what we can do is then you're going to read the button and pulse the clock and then read the button, pulse the clock, read the button. Now what happens is I'm going to do that 8 times because I have 8 buttons. So first is I'm going to set up a loop for 8 times around. I'm going to have my buttons array, the position in it wherever I am up to the loops. To begin with, it's 1. And I'm just going to read the data value of the data pin and store it there. Then I'm going to pulse the clock, low then high, loop around again, read the data, store it in the buttons array. Pulse the clock, loop around again, read the buttons, store it in the pulse array. So I've gone around 8 times and I have the 8 values stored in the button array. Then the function is going to return that buttons. Then down the bottom I've just written my little main routine which just says button state equals read NESS, call that there, and then print it to the screen. So if we go over here and I hit run, you'll see it just does a whole heap of ones. Ones. If I press that button, the second one turns to 0. Take my feet off, it turns back to 1. Turns to 0, turns back to 1. If I press that button, turns to 0, turns to 0, turns to 0, it comes up. Press that button, that one turns to 0. Come up. Press that button. That one turns to 0. With this control, that one's that way. Getting in my hand right. That one's that one. You can see him turns to 0, turns to 1, turns back, turns 1. So you can tell which buttons test. If you press 2 buttons at once, 2 of them will turn to 0. You can see 2 of them turn to 0. Take the hand off there. If I press maybe that one and that one, if we can get both of them down. Those 2 there. So it can tell you the state of all the buttons. And this one here is actually a rapid fire button. So if I press that button there, it turns the very second one to 0 and keeps it 0 while I hold it down. But if I press that button and hold him down, you see it goes 1 0 1 0 1 0 1 0. So it's just a rapid fire button for that button. It's not a separate button, but rather a rapid fire for the same button. The same with this one here. That one turns that one to 0. If I press that one down, it goes 1 0 1 0 1 0 1 0. It's just a rapid fire button. So now we have a nice little routine for reading the state of the buttons, and we can call it any time we want and know what the button state is. Very, very simple. So I might look at putting that on a few robots. I'm going to drive a few robots around with my old school NES controller. Now, if you have multiple controllers, you don't need to use extra pins on your microcontroller for all the lines. The only extra pin you'll need is a separate data line for each controller. You'll run the same latch and the same clock and obviously the same power and the same return for all of them. So I don't have a second controller, but I've wrote up the program I would use if I had a second controller, and you do the same thing if you have a third controller, fourth controller, fifth controller. So what I've done is I've set up the extra data line here. So I've said the data line for the second one is in pin 28. Right, so I've made one more pin. And what I've done here is I've made a second array to store the state of the second controller. And then all of this is the same, but when I'm reading it, I'll read buttons for the loop like I did before for the first controller, and I'll read buttons 2 for the second controller. And then that'll go round and round and round, so I'm reading 2 controllers at once, And then when I return it, I'll return an array that has both the first buttons and the second buttons. If you had 3 controllers or 4 controllers or 5 controllers, you could just keep adding it on like that. And all you need is one more data line coming from your microcontroller or Raspberry Pi or whatever you're using, and you just run the same latch line, the same clock line, the same V+ line, the same ground line to all your controllers. All right?